motion word problems. The last type of applied word problem that we'll talk about are motion problems. Whenever we encounter a motion problem, we are going to use the following formula. D equals R times equals rate times time. Certainly we could interchange each side of the equal sign and use the formula rate times time equals distance. So throughout the following examples, I will be using this formula. Let's take a look at a pretty straightforward example. Let's say you drove for 4 hours at an average rate of 55 miles per hour, and we want to find the total distance traveled. Rate times time equals distance. When I do these problems, I'm going to draw a little chart. So I'll put R here, I'll put my T here, and I'll put my D here. And what we want to do, we want to fill in the chart with the appropriate values. So let's look at our example. And I'll put 4H for 4 hours. And under rate, the R column, okay. Now if I want to know the distance, I is 220. And notice when I multiply straight across, my hour component is going to cancel, and I'm left with 55 times 4 miles. Two airplanes leave Chicago at the same time and fly in opposite directions. One travels at 450 miles per hour, the other at 550 miles per hour. We want to figure out how long will it take for them to be 4,000 miles apart. Well, let's try to represent this word problem with a picture of some sort. So let's say that this dot represents Chicago, and we have one airplane going the opposite. Now let's just label a little bit here. Let's draw a little airplane. Rate is the 450 miles per hour. And we have another airplane going in this direction. Now, we want to know how long will it take for them to be 4,000 miles apart. So this distance plus this distance. So I think I have somewhat of a diagram of what's going on in this problem. So we have rate times time is equal to distance. Now let's see, I have an airplane going 450 miles per hour, so I'm going to label that airplane as the slow. Well, the slower airplane is going 450. The faster airplane is going 550. Well, we're looking for the time. Actually, yes, we're looking for the time that it takes for them to be So how about if I let t be my variable time? And notice that the times are equal. This is the unknown quantity that we need to solve for. Well, I know that rate times time equals distance. So 450 times t gives me 450 t. That's going to represent the slow airplane's distance. Similar, and that gives me the faster airplanes. This distance is 450 t. I know that this one is 550 t, and I know that they have to add up. Equation. Now let's just try to solve it real quick. Or 1,000 t equals 4,000. Divide both sides by 1,000. So t worse. So what did we find out? Well, it's going to take 4 hours for these planes to be 4,000 miles apart from each other. Okay, Pete starts walking at 4 miles per hour. An hour and a half later, Kathy starts running along the same route at 6 miles per hour. How long will it take Kathy to catch up to Pete? Well, again, I'm going to try to draw some type of picture or diagram to help me figure out what's going on here. So let's say there's the walking along this path. Now Kathy is going to start running along the same path. And we want to figure out how long is it going to take Kathy to catch up to Pete. So notice eventually Kathy and Pete will be going. So let's draw our little diagram, our little table. I've got rate times time is equal to distance. Now let's look at the problem here. How long will it take Kathy to catch up to Pete? So the unknown quantity that we're trying to solve for is Kathy's time. So over here on the side, I'll let t equal Kathy's time. Try to fill in the rest. Oh, let's try to fill in Pete's rate. Now notice, this is the most difficult component to figure out here. Let's see if we can figure out what Pete's time is. Actually walking for, let's see, an hour and a half longer than it takes Kathy. Well, if it takes Kathy t hours, then Pete must be walking t plus an hour and a half. 3/2 is the fraction for 1.5. So Pete's time is Kathy's time plus an hour and a half. Now notice, this one must be 6t. Now let's figure out an equation. Well, the whole point of the problem is to Pete. So notice, so here's Pete's distance. It must equal Kathy's distance. So the equation then must be Pete's distance why don't we distribute the 4 through? Let's see, 4 times 3/2, I can cancel the 2. 6. I'll subtract my 4t to both sides. I have solved for t. Up, well, t was the variable Kathy's time. That's exactly what we wanted to solve for. So Kathy's time was 3. It took her exactly 3 hours to catch up to Pete. Now you may want to review this segment of our lectures a couple times. These problems can be tricky, but if you look over these a couple times, it should make sense to you after a while.